Okay, so this video is going to be on multiplying polynomials. And okay, so multiplying polynomials. So a lot of these, it kind of uses a lot of the things we've been learning in chapter 5 in this textbook, but we start with the idea of like FOIL. So remember, FOIL is just the idea of multiplying two binomials, which you should have seen somewhere along the line, or maybe not. So we have two binomials being multiplied together. We've already done monomials. Remember, like one term times one term, or distributive property where it's one term times two. But this is now, we have two plus and minus signs, or two terms binomial times two terms binomial. And when you do these, you need four multiplications. You start with the first one and you make sure it multiplies by both terms here, and then the 2 has to be multiplied by both terms. So everything is touched in that process. So let's do this one. X times x is x squared, right? 1 plus 1 make 2. And then x times negative 3 is negative 3x. Okay? And then 2 times x is 2x. 2 times negative 3 is negative 6. Right? So we've done the four multiplications. That's what FOIL actually stands for. First, outer, inner, last. It's just four multiplications. So I kind of think of FOIL for four multiplications. Then you have to look for like terms, which the middle two sometimes are, and they are on this one. Negative 3 plus 2 is negative 1x. You don't have to write the 1. And that's our final answer for this one. Okay, you do a lot of problems like that one. Another way to write somewhat similar problem is, this is actually the same problem. It doesn't quite look like it. That's why I'm doing this one as another example. Is it's saying this whole thing squared. A lot of people try to do some kind of weird shortcut, and there isn't a shortcut. You can't just square them. That's not what it's telling you. It's saying this entire thing is squared. So that means it's the same as this times itself. So then you have to make sure you do all those multiplications. So same thing. So first, 2x times 2x is going to give us 4x squared. 2x times 4 is 8x. And then you switch to the 4. 4 times 2x is 8x. And then 4 times 4 is 16. Now we can combine those middle, we have the 4x squared, combine the middle two terms to get 16x, and then we have the 16. So we combine the middle terms right there into 16. So don't mess those ones up. Make sure you realize that when you're squaring it, you rewrite them out, and you've got to get that middle term in there. Right? What if I asked, I could ask something to the third power, like the one above, and you would have to do 3 of them. Okay, that means you do 2 of them, get an answer, and then multiply it by the third one. So that really does take a lot of steps. But this one is similar, and I want to do it because it's written kind of different. And I thought, if it's in one of my textbooks that has problems like this, and one of them doesn't. So, but it kind of uses the idea of to the third power, or I mean, it's just a longer problem. What is this really telling us? Well, we're saying this whole inside part is squared. Let's see if we can simplify this. It's saying this one plus this one. Well, none of these have like terms for adding, so we can rewrite that middle part really just to be 5x plus 1 plus 6y squared. It's really a trinomial. That's all it is. It's kind of written weird, and you're squaring it, which means you then times it by itself. Okay, so that's how you get rid of the square, right? Times them by itself. So that's not really needed there. So let's start with the 5x being multiplied by all 3, and then the 1 being multiplied by all 3, and then the 6 being multiplied by all 3. How many multiplications is that? 3 times 3. We're going to end up with 9. It's a lot. So 5x times 5x, 25x squared. 5x times 1 is 5x. 5x times 6y is going to be 30xy. Okay. Then we switch to the 1. 1 times 5x is 5x. 1 times 1 is 1. 1 times 6y is 6y. Then we switch to the 6y. 6y times 5x is 30xy. Then 6y times 1 is 6y. 6y times 6y is a positive 36y squared. All right, so like I promised, there's 3, 4, 5, 6, 7, 8, 9. Woo! 9 of those. Now let's write down, combine our like terms. So the first one there's no other x squared. So I'm just going to write that one down. And we're done with that one. Then we move to 5x. Is there another x? Yes, there's one here. So 5x and 5x are going to make 10x. So that one's done, that one's done. xy, xy, and if you would have wrote that yx, it's still the same letters with the same exponents. We just have to pick a way to write them down here. We usually like to do alphabetical order. But 30 plus 30 makes 60 of those xy's. Oops, forgot 0. 60 xy's. Those ones are gone. And then we have a 1. There's no other 1. And then a 6y, 6y is 12y. And then 36y squared. Whew! That's our answer. The hardest part is if you have to type that into my math lab. That might take a while. Okay. Remember the shortcut of above the 6 is to do an exponent. So you don't have to click the exponent part. But that is the final answer for that one. Now let's look at this same idea in function notation. So if I say f of x is equal to, I don't know, 2x squared plus 1. And if I say g of x is equal to x plus 3. So those are my f, that's my g. This is my fourth question. What if I asked what f of g is? Fg of x. What am I asking in function notation? Well, I'm saying what is function f times g, right? When we write them next to each other, it really is just times. So f times g. So f is 2x squared plus 1 times g, x plus 3. So I'm really foiling those out. Sometimes you can just put them in like this and it'll accept that as your answer. And sometimes you have to distribute it and actually multiply it. Most of them are going to make you multiply. So 2x times x is 2x to the third, or squared times 1 more makes 3, right? And then 2x squared times 3 is 6x squared. Then switch to the 1. 1 times x is x. 1 times 3 is 3. And then I don't have like terms on this one, so I'm actually done. Okay. You might be asked for g of f. Is that different? Or g, not of f, that's composite functions, but g times f. Is that different than f times g? I'll make you think about that. But of course you could pause it and think, I guess, more. But no, multiplication is the same no matter which direction you go. If it's composite functions that we did in the last section, yeah, it's very different. Or if it's subtraction, it's different. If it's division, it's different. But multiplication and addition are the same no matter which direction you go. But I will write it in the way that we see. This says g of f of 0. Let's go with the 0, what that means in just a second. We know this is g of f is g times f. That's our first look at it, but we don't put in an x. We don't keep it in terms of x. We want to put in a 0. So we put in the 0 plus 3 and 2 times 0 squared plus 1, and we calculate that out. So when you're given a number, you write them out as multiplication, but then you put the number in for each of the letters. So let's see what we get. 0 plus 3 is 3. And 0 squared is 0. 0 times 2 is 0. 0 plus 1 is 1. So what is 3 times 1 is 3. So our final answer is 3. So that's kind of an overview of multiplication. Whether you see it in function notation or you see it written out, either way, just go slow and make sure you combine your like terms right.